try and get it working.
Thank you. Right, okay, moving on. Exasol. So, Graham, would you like to?
Yep. So let me share my screen.
Could you turn your sound up very slightly because you're quite faint?
Sound. Just hang on.
Sometimes you have to just lean forward.
Yeah, bring your mic forward.
Maybe that's better, is it?
Yes, it is better.
Yeah.
Thank you.
Yeah. Well, let's give it a go. You can see my screen now, hopefully.
Yes.
Yep. So, yeah, quick intro to me. I've been at Exasol for 5 months, but prior to Exasol, I spent 22 years with Adidas, hence the clothes, because I don't have any others. Yeah, here in Germany, I'm down in Bavaria near Nuremberg. I've always been in data-related roles, so managing BI teams or analytics teams. Yeah, been around the world, worked with all the different departments, finance, supply chain, you name it. So fair to say I've seen the good, the bad, and the ugly of everything that data and analytics has to throw at us. Yeah, I think, I mean, if I look at the highlights, building the consumer DNA factory, the last 5 years at Adidas, and watching their e-com business grow from nothing to 4.5 billion over the last 5 years. And the analytics that we provided played a huge part over that. Anyhow, that's enough about me. The data lakehouse, that's why we're here today, to talk about the hype around it as much as anything. Really, this is a topic that we at Exasol had to have a look at because no one really knew what we were talking about. The term data lakehouse started to crop up an awful lot in the last 6 months. And we were sat looking at ourselves saying, well, what does it really mean? What are we talking about? So hopefully, yeah, let's go through and try and understand what it is and try and give us a description of where we're going. So we'll talk about the data lakehouse. There's 2 scenarios that I'll put in front of you. We'll describe those. We'll have a look at what are the problems behind the lakehouse. We'll say why are we even talking about it in the first place? Why is it trending? Why is it at such a hype at the moment? Maybe look at the alternatives, when to use it and when not to use it. And then we'll try and answer the question at the end, should it be part of your analytics strategy? So let's jump right in. What is a data lakehouse? Well, actually, I'll go back. Let's look at the history first. So the data lake itself, that term was coined back in 2010. James Dixon, CTO of Pentaho. That's a very widely accepted term now. But the lakehouse, that only came up in about 2016. So it has been around a while, but it hasn't been talked about as much. There's actually a guy called Pedro Javier Gonzalez Alonso, obviously liked names and created the lakehouse as a new term as part of his thesis. Yeah, back in 2016. So it's taken a bit of a while to come forward, but probably one of the reasons is it's now being used very much as a marketing term by the companies that are using it. So the first scenario is very much related to Amazon and their AWS stack, so that their web services world. So whenever Amazon talk about the lakehouse, they're talking about the tools that they offer that sit around and above the lake. So right in the middle there, for the picture, you've got the typical S3. Hopefully, most of you are aware of that platform. That's the raw data lake where you're throwing in, your bucket loads of data, everything you can get your hands on. you're throwing it into the lake and storing it there. And then, Amazon has a plethora of tools that they then make available that sit above that lake. So in that diagram, you can see, you've got even 3 different types of database. There's one for every use case. So you've got Aurora for OLTP type, transaction processing world. You've got Redshift for the more analytical side of things, OLAP capabilities. You've got DynamoDB as the NoSQL tool, which is great for streaming data into at a fast rate. And then you've got tools like SageMaker, the machine learning world of Amazon. And they've got thin dotted lines, even on this is the Amazon diagram themselves. So you've got kind of this thin dotted line between them, which tends to indicate that that these tools are linked, but it's a weak link. Typically, to move data between 2 of these tools, you've got to export your data as a CSV file, send it back down to the data lake, and then re-import it back into one of the other tools. Very rarely do you have the ability to move data directly between the tools. So Amazon's calling their lakehouse architecture this collection of tools that sit above the lake. So that's one option we've got, one version of the lakehouse. The other version, which is perhaps more interesting for us, is the Databricks version. Databricks is a company that it came from the original creators of the Apache Spark platform out in California. So you have these group of people working on this open Apache Spark world. Once that was up and running, they then gave that to the world and moved on to create Databricks, the company. So very much a financial opportunity for them to make money out of what they'd created in terms of this open Spark platform. So of course, from a Databricks point of view, their core direction is to bring everything they possibly can back towards this Spark-based world of processing. So you can see in the diagram there, over time, you've had the data warehouse, we've had the data lake coming in from 2010 onwards. And what Databricks are now trying to do, and have quite successfully done, is create this additional layer on top of the lake. I don't know if you can see my mouse there, but in this right-hand part of the diagram, we've got this it's like the surface of the lake, if you like, where they're doing additional level of processing, and they've created an additional layer of abstraction, if you like, which allows them to then create even more tools based on Spark that can talk to this surface layer, in theory, without having to take the data out of the lake. So the benefits, that Databricks guys are saying is that they solve a couple of the problems that were associated with your typical data warehouse and also with the data lake. So the argument against the data warehouse is that it has a schema and it's very, very structured and therefore can't handle all the unstructured data that typically is now sitting in a data lake. So the images, the text, the voice, the files, those kind of unstructured data that is perhaps more and more becoming useful in the world of machine learning, for example. It's traditionally that's not a strong part of data warehouse. And on the other side, you've got the data lake, which is messy. Yeah, it completely lacks structure of any kind, typically leading to your data swamp. And that old question, well, I've got a data lake, I've got all my data in it, but now what? So there's that gap in the middle that Databricks is trying to fill with this surface layer, if you like. But one thing to look at, if you look at any of the data coming from, or the documents coming from Databricks, they never ever mention analytical warehouses, which we'll come to that later. So another way of looking at that is down at the bottom, you've got your data lake. There's no schemas involved. So it's a schema on read process. Up at the top, you've got your classical data warehouse, which is schema on write. So you're bringing the structure, you're bringing the data together in a format that makes it very easy and very quick to analyze and access. And then going for this version in the middle, which is the so-called flexible schema. So they're not going all the way towards the full relational database, but they are for sure creating a layer of cleaned up and relational data on top of your typical lake. And that's typically pushing your data into, one of the formats on that right hand side, the Parquet or Avro type format for your file, which is, basically saying, yes, we've realized that data lakes are great, but there's no way you're going to get the performance and the speed that you need to analyze this data unless we at least take one step towards cleaning up the data and putting it in a format that we can access and process quickly. So for me, that's the only real difference. It's this extra layer that they're creating. So let's have a look at what that really looks like in terms of speed and performance and costs. So on the left-hand side of the diagram here, you've got the pure lake, and the colours are supposed to represent the speed of access, the ease of access, and the performance that you're going to get from the different options. And the pictures at the bottom are just a way of trying to show that as well. So, the deep lake is perhaps, in terms of speed, it's the old mainframe, big tape machines. Don't know if any of you are old enough to remember that. I certainly am, but there you go. And then we've got this new surface layer sitting on top of that, still Spark based, still in your lake, but it's cleaned up and it is formatted. It is relational to a degree. If you pull the data out of the lake into a tool like Amazon Redshift or Azure SQL, it's getting quicker. It's always going to be quicker. You're now adding that full OLTP capability or NoSQL if it's MongoDB, something like that. So you're getting it faster. You've added another level of capability, if you like. So we're moving from the CD type world of the cold surface lake to the DVD or the SSD disk world, if you like. But the downside of that is that we're moving to proprietary formats. As soon as you pull the data out of the lake, you're putting it into a format that's specific to the supplier, whether it's Google, whether it's Microsoft, whether it's Amazon. And then if you really want to go for the fast and the pure performance level, then you're going for an analytics database, which is, the real hot, quick data. And that's where, that's in memory. So your RAM picture there is a good indication of the speed that you're going to get there. It's the fastest you're going to possibly get. And it's got all those nice column-based capabilities. It's MPP, all those nice things. So the other version of looking at that is from a complexity point of view. If the arrow is going the other way in this case, so the complexity is increasing as we're pushing the data down. So if you're working on the deep lake, you're working in command line code, very, very basic. And it's the same if you're on the surface at the moment. When the cloud technology came in, it was based on the back of Hadoop. And for me, that was a backward step certainly in the technology world, because we've been on this path towards low code and GUI based tools, which really made a huge difference in terms of connecting to business and getting business people involved and giving them self-service capabilities. And then all of a sudden we went for this cloud-based, Hadoop-based capability, and we went back to almost, assembly language kind of world. Everything was really, really complicated again. So again, on the other side of that line, when we get into proper relational databases and we start using SQL again, we're going back towards that low code and ease of use. Especially when we get to the high end, then these databases available these days are completely self-tuning. You don't need a database administrator even. So benefits, performance, complexity, yeah, it's a big picture, and we're going to really look into that. And that brings us why is this topical and trending at the moment? I think a lot of the reasons behind that you can see here. So first part is really the failure of Hadoop to deliver scalable computing capability. So the storage side, which is why it was created in the first place, was fine. But as soon as you try to do anything with the data that you store, you really hit problems because of that complexity side of things. So that brought along, the public clouds, the AWS cloud, these Microsoft Azure, Google Cloud. And they've been a huge success because they've taken away the complexity of the Hadoop world. Azure and Google are still based on Hadoop. AWS is based on something very similar, their S3 world, but it's all hidden from you. It's very, very simple, and it's incredibly cheap. So, I think it was something like 2.1 cents per gigabyte per month to store data in AWS. So that's been a huge success. But again, that's brought the problem of everyone's thrown the data into the cloud and they've not considered the cost of actually accessing and using that data. So as soon as you've gone down that path of migrating everything to the cloud, great. The costs of using the cloud, computing in the cloud, suddenly start to get astronomically high. You start to ramp up, and your volumes start to get big. A lot of companies that we're talking to, and I certainly saw this at Adidas, you're spending millions. The storage cost is nothing, but the compute cost is incredibly high. And it's very, very difficult to forecast. It's very, very, very difficult to follow, to know to track what you're using. Another side is that there are very few options at the top in terms of the analytical database world. There really are only two real options: Exasol and Snowflake. The rest of the options out there, if we talk about Redshift, if we talk about Azure, they're all tools that were ported from traditional on-premise systems to the cloud. So Redshift was bought from PowerXL. It's a port of the old Postgres SQL 8 database. And that was a pure attempt by Amazon to shift away from Oracle, because to Amazon, Oracle was always known as Big Red. And that's why it's called Redshift. They just wanted to shift consumers away from Oracle. They used any means they could. Azure is the same. Azure SQL is based on the Microsoft SQL Server family, related services around it. So they're just ports from traditional existing on-premise solutions to the cloud. And that means, they're always going to be a little bit restricted in terms of performance. They're not pure breadth. And then you've got this drive of the Apache open community as well behind all this. So, this desperation, there's a community that is really, really bought into the whole Apache Spark world. And they're driving that whole capability as fast as they possibly can. So what does that mean? Well, in terms of, is and when the lake house the right choice? Maybe a couple of things that we can look at that will help us determine if that's going to be good for us on. Elasticity. If you're in a position where you only do big jobs on an irregular basis and you only need that computing power every now and again, then maybe it's a good choice. Pay for what you use. Don't have this massive big system that is sat idle most of the time. The connectivity part, if you bought into a particular cloud vendor or whatever, it might be that using all their tools together is going to give you a benefit because of the connectivity. But as we saw with Amazon, that connectivity doesn't tend to be there at the moment. If you're really bothered about redundancy of your data and you really only want to store it once and never pull it out from your lake and put it into a proprietary, fast and performant technology, then fine, the lake's for you. So down at the bottom there, we've got the two options. Maybe that's one way of trying to put a black and white version on it. If your analytics is one time and very focused on a very small part of your business, then maybe the lake house is good for you. But if you're doing standard and repeatable topics and analytical jobs all the time, 24/7, maybe you want to be going the other way and having an analytics database. You're going to have to fit it to what your data and analytics strategy is. But maybe there's a case for both together. Let's have a look at the diagram. Hopefully this makes sense to you. So let's see what we've got down at the bottom. We've got our data sources, typical enterprise data sources, Microsoft Vision, all your social media and your web data. You're throwing that all into your data lake. Bottom. On the top of the data lake, we've got this structured layer that we've talked about. That's now in Parquet format, possibly, or one of those new formats. And this is where Databricks and a couple of other players are in the market. So they're bringing the data and using the data from this additional surface layer, but it's always going to be based on this open technology. So it's never going to be all pervasive. It's never going to cover your entire traditional data warehouse. You're going to be working in smaller chunks of data. And these guys are saying they're giving you the speed and the capability of actually working in a more proprietary format. Got to try that out for yourselves and check the numbers directly. They never stack up because it's physically not possible. If we go back to that diagram with the RAM, picture of the RAM and the picture of this DVD player, it's that story. You cannot process files as fast as you can process stuff that's in memory. So these guys all have. So the Databricks and that, they always have this in-memory caches to speed things up, but those caches are always going to be limited in size. So what we typically see is, and maybe what a good alternative is to use your Databricks as your layer to handle the lake, to provide the metadata around the lake and to answer that question. I've got my lake, what's in it? So it gives you a structure around your lake. And then you still need perhaps a pure play analytics database on top to give you the power and the performance that's going to drive your analytics for your business at the speed that they really require and at the volume that they really require. So I've used Amazon as the example there with Amazon Blue, Amazon Redshift, and there's different scenarios. You know, whether you use Exasol is obviously the analytics database I've used in this example, and you can use it as an accelerator, cloud data warehouse, or a pure play analytics database. But in each case, you're going to want to sit it on top of either your lake, Databricks, possibly even Redshift. It's because it's going to give you the speed above that as well. But it's two very separate things. The lake house is just wedge in the middle, if you like. It's giving you an extra option to speed things up over the pure lake itself. But one thing to take away is it's never going to be as fast as the layer on top. So yeah, so to answer the question, should a lake house be part of your analytics strategy? Well, the answer is, of course, I'm not going to say yes or no. It's maybe. There is no silver bullet at the moment to answer the question about how to handle the data in your lake and what's the best alternative and what's the best solution for giving you the right volumes, the right speed, at the right cost, and the right simplicity. Maybe that hybrid solution is going to be the best of both worlds for some time to come. I just say, keep an open mind and consider all your options. So that's all I've got to say. Hopefully we've got some time for some questions and hopefully I can give you some answers.
Great, thanks, Graham. Is there anyone got any questions?
Well, I've got some points I'd like to make. Thank you, Graham. Actually, I won't lie. I started that presentation hearing data lakehouse, thinking here's yet another buzzword and some like funky term they want to use in the data science space, and actually came at the end of it and actually went, okay, that's quite good. I understand what he's bringing to that. So no, thank you, Graham. I think sorry,
that was my main point. It's this hype and no one understanding it, and I'm on this kind of evangelical path to try and clear everyone's heads about what it actually means. Sorry, go on, carry on.
Yeah, no, it's because that was quite useful in framing a few things. Just for the purposes of context, Whitbread, we've got everything Azure in the cloud. We do have a structured data warehouse built from a lot of the data we're sort of storing in our data lake. So we have a structured data sets and all the right sort of visualization tools on that. But then we also have Databricks acting in the sort of way that you describe, sitting over that same sort of data lake of data, which gets built into the structured data warehouse to offer us some of those more advanced capabilities. And let's be honest with you, whilst, I maybe like a few other people on the call, a bit more long in the tooth, maybe might look at some of this stuff and go, oh God, this is racing ahead really fast. And it is racing ahead really fast. It is so powerful. And, the ability to use some of that unstructured data, text analytics and image analytics, the ability to run 500 different styles of regression models in about 5 minutes, which would otherwise have taken you in the old days when I was doing them with Martin on the call. That would probably take you a good couple of weeks to run that many. And so it's very powerful, and it is raising the profile of the analyst. I just wanted to just flag that it's easy to go shiny new technology. Oh my God, what can all us old analysts bring to the party? And I think there's a couple of things which have really struck me seeing data science sort of taking off within Whitbread. I think number one, data scientists start to focus a lot more on how they're doing things rather than what it is they're trying to do and the so what as the outcome. And a certain wise man, is called Mr. Martin Callingham, who used to be my boss, said to me, the stakeholder won't care about how you've done that analysis. They'll just want to know it's done properly. What does it mean? But you are finding increasingly in the data science community, they're getting obsessed with their deep forest clusters or whatever it is this week. And the how isn't actually important. It's about how reliable the outcome is. So I think that's a mantra that still needs to be driven and managed quite carefully in this sort of circle. I think the second thing is around sort of that dirty word of governance, really, which is something I'm quite hot on. But in the specifics of sort of data science, I've reflected on the fact that, yeah, whilst everything is cheap to store in the cloud, you're absolutely right, Graham, it's quite expensive to compute it. But the more people that you're driving to do that, you're suddenly having to build in this governance layer that sort of basically helps throttle the everyone's usage to make sure the budget doesn't go through the roof. And this is something data scientists don't want to do. They're more sort of free jazz players. They don't want to work with constraints. They want to just get on and do things. They don't want to have to work within the constraints of verse, chorus, verse, chorus. So, you're almost finding elements of policing or self-policing of varying levels of success within the data science environment, not least as well about having to sort of challenge on questions of data quality. It's great that you can go to the data lake and construct data in a really quick way, in a much more flexible way. But often this is to the degradation of overall data quality, which is normally much more managed in a structured data warehouse. So which then comes back to that sort of what that Martin used to drum into me when I was a young analyst, is if you're building these insights on shifting sands because you've constructed it from a data lake, so therefore it's not as high data quality as the data warehouse, where are you? So you have to be constantly challenging these sort of themes to ensure that your data scientists are creating the right stuff. But just like death and taxes, change is inevitable, and this is the change, and it is powerful. It's about how can we ride on the back of the data science boom, but ensure that it's not done without that focus on the output and the quality of the performance of the individuals and the quality of the performance of the systems.
Absolutely, totally agree with everything you said. I mean, it raises, if you look at it from that point of view of self-service capabilities, I think the data science world is moving rapidly. I think the times of pure data scientists is rapidly coming to an end. I think the need for business analysts with the ability to do data science, even if they don't know they're doing it, is coming to us. It's a said the simplification of the tools that they're using these days means that you can put an Alteryx in the hands of a business user, and he can now do regression testing, all those nice basic machine learning techniques without really knowing any of the details behind it.
Sorry, Graham, can I just?
Oh, yeah, I was just going to say it's a fascinating topic, and I'm sure we could go on. And Graham, I massively love to go against what you just said, but I'm running out of time. So I do love the topic, and it's great to hear what people's contributing in there.